Milky Way, home to hundreds of billions of stars, ranging from dim, explosive red dwarfs to short-lived blazing giants. But in the middle are stars like our sun.
Strictly speaking, if we really want Earth 2.0, we need to look for planets around stars like our sun.
Stars like our sun are calm and stable, with long lives. And the habitable zone lies far enough away that planets avoid tidal locking. We stand a much better chance of colonizing a planet around a sun-like star.
We're hunting for planets in the habitable zone of stars like our own sun, and we have found worlds there.
Worlds like Kepler 452b, an exoplanet 1,800 light-years away, orbiting the same type of star as our sun.
You really couldn't ask for a more Earth-like orbit around the star. The year is about 385 days. We're 365 days. This really is very much like the Earth.
The planet orbits its star at roughly the same distance as the Earth orbits the sun, and could be very much like home.
Kepler 452b is in the habitable zone of its star. So if there is liquid water there, there could be oceans and lakes and rivers and streams and blue skies and cloudy days.
Sounds nice, but Kepler 452b is a lot larger than Earth.
Kepler 452b is a great Earth 2.0 candidate, but it's sort of like Earth on steroids.
This world is about 5 times more massive than our own planet and about 60% wider.
Scientists call large worlds like Kepler 452b super-Earths.
These worlds are maybe 1.5 or 2 times the size of the Earth, with maybe as much as 10 times the mass.
Could this supersized Earth-like planet be our second home?
A planet like this seems to meet a lot of our standards for an Earth 2.0. It's around a star like our sun. It's smack dab in the middle of the habitable zone. The problem is there are other factors at play. One of those is simply the mass of the planet.
Kepler 452b's size has an extreme effect on its gravity.
Because of its incredible mass, the gravity on the surface is about twice what we feel here on the Earth.
That extra gravity would make colonizing the planet difficult.
Just about any chore you can imagine doing that you don't like doing on the Earth, you're going to like it even less on a planet like that. When the garbage can weighs twice as much as it does here on the Earth, that's not going to be very much fun.
Maybe LeBron James and I will be okay, but normal humans, I'm not so sure.
And we could be stuck on the planet's surface.
If you landed on the surface of one of these super Earths, it'd be pretty easy to get down onto the surface, but it would be very difficult to get back up.
It's already incredibly difficult for us to leave the Earth. Think of our giant engines and rockets, these incredible miracles of engineering that we need to blast off. You need twice that to get off of Kepler 452b.
And to make matters worse, Kepler 452b's atmosphere is thought to be radically different from Earth's.
In some sense, how big the planet is, how massive it is, will determine what its atmosphere is like. If you have a lot of mass and a lot of gravity, you can hold on to a lot of air.
You're gonna have a much larger atmosphere, much thicker, much denser, and higher pressure at the surface.
A thick atmosphere could trap heat from the star. Surface temperatures become ferociously hot, and crushing pressures make the surface completely uninhabitable.
So it's possible this planet has a very thick atmosphere that's become more of a runaway greenhouse effect. The planet's gotten hotter and hotter over time. Maybe instead of finding an Earth 2.0, what we found is a Venus 2.0.
Super Earths may have an appealing name, but their intense gravity would make them difficult to live on, and we could not survive in their thick atmospheres. So far, all the worlds we found have turned out to be uninhabitable. But what if our new home is not a planet?
Earth 2.0 may not be an exoplanet at all. It might be an exomoon.
We live in a cosmic shooting range where planets die every day. But backup planets like our own seem almost impossible to find. Have we been looking for the wrong thing?
I think there's a pretty good chance that Earth 2.0 might not be a planet per se, but actually a moon of a giant planet.
The exciting thing about an exomoon is that they could potentially be habitable.
So is it possible that as we look at different solar systems, the real analog for Earth 2.0 will turn out to be an exomoon?
In 2017. The Kepler telescope scanned a sun-like star 8,000 light-years away, and Professor David Kipping and his team watched the transiting exoplanet, Kepler 1625b.
Kepler 1625 was one of the many thousands of planets discovered by Kepler, but what made it different from our perspective as a moon hunter was that this is a planet which was Jupiter-sized, far away from its star, and apparently on a near-circular orbit. So everything that we want for finding exomoons.
The exoplanet Kepler 1625b is an uninhabitable gas giant, like Jupiter. But it is in the habitable zone, and that means its moons would be too. Unfortunately, these exomoons are incredibly hard to see.
The way that Kepler finds exoplanets out there, it really does relate to the size of the planet. And for moons, it's much, much more difficult because it's smaller, so it's harder to detect.
The largest moon in the solar system is Ganymede around Jupiter. It's about 40% the size of the Earth. And we really very rarely detect planets that small. So of course, looking for exomoons is going to be very, very challenging.
In 2018, the team recruited the powerful Hubble Space Telescope and used the data to hunt for the tiny silhouettes of any moons.
If you have an exomoon orbiting a planet, sometimes it's going to lead the planet when it transits the star, and sometimes it's going to trail behind as it transits the star, and you see a little bump in the transit dip itself at different places.
And the team detected the signal. Not one, but two objects orbiting together. Confirmation of the first exomoon ever discovered.
It was an amazing discovery. I've been looking for exomoons my entire career. For 10 years, we have been in this quest to try and find these things.
This discovery, this announcement was absolutely remarkable.
Not only does it mean that we might find Earth twins everywhere in the Milky Way, but it gives us something to strive for human exploration.
On this alien exomoon, the skies would be nothing like Earth's.
Visually, I think it'd be an absolutely stunning place to be. You look up in the sky and you see this ringed planet looming huge in the sky.
A world that could be like Earth, only orbiting another planet. But don't pack your spacesuit just yet.
Even though the planet and the moon are potentially the right distance away from the star that we might imagine there being liquid water on the surface, both the moon and the planet are likely gaseous objects with no solid surface to speak of.
Although the moon probably isn't habitable, it is an important step for finding worlds like our own in the galaxy.
If we find exomoons around exoplanets, that potentially hugely increases the number of habitable worlds that are out there.
We just need more accurate measurements, and then all of a sudden, the universe is going to be full of exomoons.
But these worlds need to be more than just Earth lookalikes.
Everyone gets very excited when we find Earth-like planets around other stars. But Earth-like kind of just means how big it is and whether it can support liquid water, where it is in relation to its star.
All of that is great, but it's just not enough.
A planet's composition could be make or break for our new home. The difference between the perfect world and a ticking time bomb.